Welcome once again to this solving of Waec past questions on electric circuits. And remember, these questions were extracted from Essential Physics textbook. Okay, so let us solve them together. If today is your first time of coming across my page, please do well by liking and following this page for more educative content. Now let's go. Look at question 21 here. Look at it here. Look at the circuit here. So this one is very easy, okay? So it's very, very easy. Look at here. We're having resistor here. We're having a resistor here. And here, this is the potential difference. So it means the same potential difference that what passes across the circuit. So in a series connection, current flows, the same current flows. But this one here, this particular connection here is a circuit connection. So the same potential difference we have across the circuit. Now, what are we asked to calculate? It says calculate the current I in the diagram above. Neglect the internal resistance of the cell. Okay, good. So it means we are not going to be needing the internal resistance. Now, before we get the current, we remember Ohm's law. Remember that what Ohm's law says that the potential difference equal to the current multiplying the resistance across the circuit. So which will now give us the current. We make in the current the subject of formula. Current will now give us equal to what? The potential difference all over what? The resistance. Now, we are not just going to use any of the resistance here. We have to get the effective resistance of the circuit. And this circuit here is what? Parallel. So for parallel connection, so we have that R1 here given to us is equal to, I think that's 3 ohms. Then R2 give it to us here is equal to 6 ohms. Okay, good. Now let us get the total resistance that is flowing across that circuit. Now we have what? 1 all over the total resistance equal to 1 all over what? R1 plus 1 all over R2. And remember, after resolving the whole of this, we are going to have what is called products. Product over what? Sum. So which means the R total is equal to product over sum, which means R1 times R2 all over R1 plus R2. Good. So now let's go to this other side. Now, so your total resistance now is now equal to R1 is 3. I think so. That's 3 times 6 all over 3 plus 6. 3 times 6 is 18. Now, 3 plus 6 is 9. So we cancel out. Then we have 2. Now, total resistance across that circuit is equal to 2 ohms. Now, let's go back to this, our formula. Okay, let's go back to this formula. So remember this formula here. So let's go back to that. So we need to use it to get the current now. Current now, I equal to potential difference all over the resistance. Now let's look at that circuit. What is the potential difference given to us there? So we need to look at it. So the potential difference there is 2. Let's go to our calculation. So which now give us 2 over what? 2. So the final answer is 1. So your I equal to 1 amp. So this is our answer. I hope you understood the working. See you in our next question. Bye.